Hello everybody, welcome back. I want to begin today with a riddle. Suppose you're at a restaurant and you see this sign posted. Good food is not cheap, cheap food is not good. Okay, here's the question for you. Are those two statements saying the same thing or different things? So, speaking logically, are those logically the same or different? To the initial ear, they sound different. Good food is not cheap. It seems to be saying, I'm only talking about good food here, and I'm going to tell you something about good food. Okay? Meanwhile, cheap food is not good is not talking about good food, it's talking about the cheap food. Take this set of all cheap food, and I'm going to tell you something about that set. Okay? So they seem like they're saying different things. But of course, there's a little bit of a symmetry at play here. So, maybe if your intuition is that it's a little subtle, then you have good intuition. It is a little subtle. And we are going to spend today's lecture talking about this riddle, okay? So in order to fully understand that statement, those two statements, and the way they relate to each other, we have to return to our discussion from the last couple of videos discussing the implication, right? So we were talking about if P and Q are statements, then P implies Q is also a statement, meaning it has a truth value. Now, its truth value depends on the truth values of P and Q, right? If P and Q are both true, then P implies Q is considered true. Or if P is false and Q is either true or false, it's also considered true. Remember the video on vacuously true statements? This is considered vacuously true. Refer back to the old video if you want a discussion about that. So the only instance in which we get a false is a P being true implying Q is false. That would be considered a false statement. Okay, so true, false, true, true. Now for today's video, I want to discuss the contrapositive. So suppose you have an implication P implies Q. The contrapositive of P implies Q is another statement with an implies in it, but also we have some negation symbols in play as well. The contrapositive of P implies Q is the statement not Q implies not P. Okay? And it is a statement. Okay? So it's going to have a truth value. And just like this, its truth value depends on the truth values of P and Q. So we've done a number of examples of these, but let's do another one. Let's figure out the truth values of not Q implies not P. Okay? So how do we do it? Well, first we need to figure out the truth values of not Q and not P. And then if this is, say, false and this is true, then we just look over and say false, true. Oh, that would have to be true for the not Q implies not P part. Okay, so that's where we're headed. Let's figure it out. So if Q is true, false, then not Q is the opposite. False, true, false, true. If P is true, true, false, false, then not P, you flip all the truth values to get false, false, true, true, okay? And now, what about the implication? What about false implies false? Is that true or false for an implication? False implies false is considered true. True implies false. That's the only one that's false. False implies true. True implies true are both true. Okay? So we've obtained this truth table for not Q implies not P. Do you notice anything interesting about this final column? True, false, true, true. It's the same column that's over here. True, false, true, true. It looks more complicated, not Q implies not P, but it has the same final column as P implies Q. Do you remember what we called that? We call those logically equivalent. No matter what P and Q are, as long as they're any statements, they could be true, they could be false, the truth value of P implies Q, whether it's a true or false, is exactly identical to the truth value of not Q implies not P. Okay, so here's a little theorem. Based off, this is our proof. These two tables match up their final columns. So, so the theorem is a statement which is of the form P implies Q, is logically equivalent to not Q implies not P. It's contrapositive. Okay, and we had some symbols to represent that. P implies Q. You have this if and only if symbols. Not Q implies not P. Okay, so that's a pretty interesting result. That those two, it's sort of symmetric, but with these negations appearing, are logically equivalent. And with that, it's time to discuss the riddle that we started this lecture with. If you saw this sign, are these two saying the same thing or different things? I encourage you to pause the video, and with the contrapositive stuff in mind, can you figure out what's going on over there? Well, good food is not cheap, cheap food is not good. Is that an implication? Is that a P implies Q? It is. You have to think about it a little differently. If F is some food, then F being good implies F is not cheap. And also flipping it around. If F is some food, then this statement is equivalent to saying F is good, the food is good, implies the food is not cheap, and F is cheap. The second statement is if you're cheap, then if your food is cheap, then your food is not good. F is cheap implies F is not good. Okay. F is food. Don't, it's nothing else. Okay. So here are two implications. Do you see how it's starting to look a lot like something and it's contrapositive? So by the theorem, F is good implies F is not cheap. F being food. So this statement, this P implies Q statement, according to this theorem, is logically equivalent to the statement. So if this is my P implies Q, it's logically equivalent to not Q. So the not of F is not cheap implies the not of P. If P is F is good, then this is the negation of F is good. Okay, does that make sense? Okay, P implies Q, not Q implies not P. Now, let's just simplify. What would be the negation of something being not cheap? I mean, it is cheap, right? That's the opposite of being not cheap. F is cheap implies, what's the negation of a piece of food being good? If it's not true that a piece of food F is good, then it's not good. And would you look at that? Cheap implies good is the second half of the sign, right? So good food being not cheap is logically equivalent to cheap food being not good. Okay. Now take a moment to pause the video and see if you can figure out, make sense of that. Just in terms of not the logic, no truth tables, just in your mind, can you make, what is it really saying? Why are these saying the same thing? What is the common thing that they're both saying? Essentially they're both saying that there's no food that's both good and cheap. Okay, that's what they're both saying. Can you convince yourself that they're both saying that? They're both saying there's no food that's both good and cheap. And you know, we also just in a video or two ago talked about intuition from set theory, right? About how these logical implications are like a subset, right? So food being good implies food is not cheap. Do you remember what the subset would be? You know, if you're in LA, then you're in California. So LA implies California. So LA is the subset of California, right? In this case, the good food is a subset of the not cheap food, right? So if this is the set of all foods, and this is the good food, this needs to be a subset of the not cheap food. What's not cheap? That's the complement of the cheap food, right? In the set theory intuition setting. So if this is the cheap food over here, then this picture is accurate because the good food is a subset of the complement of the cheap food, right? Everything that's not in this circle is the not cheap food, and we want the good food to be a subset of that. What about the cheap implies not good? Do you see how the picture is exactly the same? Well, now what it's saying is that the cheap food, if you look at it as a circle, as a subset of all the foods, the cheap food must be a subset of the not good food, right? The complement of the good food. It's the same picture. All it's saying is there's no overlap between these two circles. And that right there is the answer to the riddle. So, the contrapositive is interesting, and it's not exactly obvious that these two should be the same. It's, you know, it requires some careful thinking, maybe even some truth tables to make it work. But once you have it boiled down very concretely, hopefully this makes sense. Spend some time thinking about it. Make sure it's completely clear in your head why those two statements are the same, logically speaking. And then you'll be ready for the next chapter, which we'll get to very soon, which is entitled The Contrapositive. That's the title of the chapter. Okay, great. So we will study proofs by contrapositive in the next chapter. That's it for today. We have just a few sections, a few short videos left in this chapter, and then we'll move on to that next chapter. Okay, hope you enjoyed that. Stay for a meme. Otherwise, I'll see you next time.